So, hello everyone. Uh, so today we are going to discuss a question from the recently came in the JEE Advanced 2026, which is from thermodynamics topic, and we are going to discuss the solution of this question, which is saying that an ideal gas, which is zero point 0.5 mole, initially at 2 bar pressure, and is compressed at a constant temperature of 600 Kelvin in two steps, in which the first step is against a constant external pressure of P bar, and P can be from 2 to 8 bar, and then against a constant external pressure of 8 bar. At each step, it is saying that at each step, the compression is stopped only when the pressure of the gas becomes equal to the external pressure. The total work done on the gas in these steps is W, considering all the possible values of P from 2 to 8, and taking the gas constant as R in joules per Kelvin per minute. The minimum value of W in joules is. So we have to tell the minimum value of W, the mode of W. What will be that? We have to tell them. So how we will do that? Let us start the solution. So what the question is saying is, we have a assume that we have a container like this. In this container have a piston like this, and this piston have a gas in it, which is 0.5 mole, and it has 2 bar pressure. And in question, it is saying that temperature for both the step is 600 Kelvin. That means temperature is constant. For whole process, the temperature is 600 Kelvin. So now, if we apply a pressure, and that pressure at which the first step is going is P pressure. Okay, and this P pressure is from 2 to 8 bar. So when we talk about the first step, this assume that this is the first step. In this first step, what happens is the gas is compressed from here to here. Okay, moles will be same. And now when this process completes, pressure will remain same P pressure. But when this distance stops, then the internal and external pressure becomes equal. That means internal pressure also becomes P bar. And in the next step, what happens is the second step. In the second step, what happens is piston comes down, but now the pressure at which this second step happens is 8 bar pressure. And when this stops, internal pressure also becomes 8 bar. So this is the whole question, which is which it is saying, and we have to calculate the total work done, minimum total work done for this step, these two steps. So how we have to calculate it? We'll see that the total work done W will be equals to W1 plus W2. And when we have to calculate W1, what is W1? When we talk about the W1, that means first step. In the first step, because it is a process of with a constant external pressure. So it is saying that the process is the irreversible process. And for a irreversible process, work done is P external into delta T. And for the first step, the P external is constant, which is P. And we don't know about the P because it is only saying that the P is from 2 to 8. We don't know it is which value is for the P. So delta V, when we talk about the delta V is nRT P2 minus nRT by P1. Okay. Now P, external pressure P, we don't know about that P, but we know about the, we can separate out minus nRT and P by P2 is our P. Final pressure will be P, internal pressure, and the initial pressure is 2 bar. It is given in the question 2 bar. So we are putting here 2 bar. So this will be the work W1, and this will be cut out. We will get minus nRT 1 minus P by 2. Similarly, we can calculate W2. This will be our first equation, and W2 will be equals to same minus P external delta V, because it is also a reversal process. So minus P external, here the external pressure is 8 bar, and nRT by the final pressure will be 8 minus nRT by, and initial pressure is here is P, because it starts from the internal pressure of P. So when we when we separate out nRT, we will get 8 by 8 minus 8 by P, and this will become minus nRT 1 minus 8 by P. So this will be the W2. This is second equation. So now we have two equations, 1 and 2. We have two equations, 1 and 2 here. So from these two equations, from adding 1 and 2, when we add 1 and 2, we will get W, which is minus nRT 1 minus P by 2 plus 1 minus 8 by 2. So this will become minus nRT 2 minus P by 2 minus 8 by 2, which can also be written as P by 2 plus 8 by P minus 2. That will be the W. So now we get this equation, and we have to calculate W minimum. We have to calculate this. So for W minimum, we have to evaluate what is P. So to calculate P, what we can do is we can use the AM GM inequality. AM GM inequality says that any number of non-integer values have AM and GM, but the AM value, that AM means the arithmetic mean. Arithmetic mean of those numbers will always be equal or greater than the GM. That means geometrical mean. And how we can calculate the AM or GM? We can calculate it like, if we have two numbers, first number is P by 2, the other number is 8 by P. So we can calculate the AM, which is P by 2 plus 8 by P divided by 2. Average of that will be always greater than or equals to root of P by 2 into 8 by P. So from here, what will be the answer? We can calculate it greater than or equals to 2 by P. And this is P by 2 plus 8 by P by 2. So P by 2 plus 8 by P will be greater than or equals to 4 by P. So now, by calculating it, P by 2 will be greater than or equals to 4 by P minus 8 by P, which can also be written as, or we can also do like that, 8 by P minus 4 by P will be greater than or equals to minus P by 2. So now we can say that the P plus 8, P by 2 plus 8 by P should be minimum value of that will be 4. So now we can put that value here in the equation, this equation, because we have to calculate the W minimum. So now W minimum will be equals to nRT 4 minus 2, which is equals to 2 nRT. Now we have to put the values only, and we will get the our final answer. Temperature is given 600, so this will be equals to 600 R. So that will be the W minimum. So this will be our final answer. So here the answer should be B option. Thank you for watching.